We normally expect things to behave the same whether they are observed or not, but that isn't always the case. When we're talking in a quantum level, which is an extremely small level, particles behave as such when they are observed and as waves when they aren't observed. To explain this, we're going to talk about one of the greatest science mysteries in the quantum world, the double slit experiment. But first, let's talk about particles and waves. Particles are little units of mass. Imagine that we shoot particles through one slit. Then we will be getting a pattern like this on a back screen. Now, if we add a second slit, we will be getting two bands of particles, and this behavior of particles is the one expected from them. And now let's talk about waves. An example of a wave is when you move a rope up and down, creating crests and throws. Looking from above, a wave will look like this, like expanding circles. There are several wave properties, and one of them is diffraction, which means the waves are reshaped by obstacles. Other properties of waves are interference pattern, which can be constructive or destructive. Both interference patterns can be seen when a wave passes through two slits. Constructive on the crests of both waves and in the same spot, and destructive when a crest meets the through of the other wave. When destructive interference happens perfectly, waves actually flatten out. When the waves interfere constructively is when we get a band of light in the back screen. And now, the double slit experiment. This experiment was performed for the first time in 1801 by Thomas Young. What he did was make light pass through two slits. It was expected to have two bands of light in the back screen, since at the time it was believed that light only behaved as a particle. That is why it was surprising to find an interference pattern there, since that pattern was expected for waves. Scientists then shoot electrons through the slits, and since it was matter, they expected two bands, but actually got many. Scientists then decided to pick, to see exactly what electrons did to cause an interference pattern like waves do, so they put small detectors on the slits to observe them. But when they were closely observed, the electrons only made two bands on the screen. It is like if the electron decided to act differently because it was being observed. Like how children behave when their parents are there and when they aren't. This led to many questions. What is matter? A wave or a particle? Thanks to this, the wave-particle duality nature came into the game. This nature states that matter can behave both as a wave and as a particle. Wow. Another surprising finding is that the observed isn't independent from the observer. What? All of this and more in the incredible world of science.